Okay, good evening. What I've decided I'll do is I'll make a video um, that'll help students extract information from a word problem and focus on the relevant parts and focus on uh, solving. But a lot of one of the things I want to stress right here, of the um, lot of the issue is reading the problem and seeing the relevant information. So what I'm going to do is I'm going to go to screen share and use a couple of things and show you the relevant information and how to do that. This is based on student questions. So we'll go here and I'll go to paint, sample meaning. First of all, let's take a look at this following question that you can see. And I think what I'll do is I'll try to, well, you get the idea. The question says, Juan makes a measurement in a chemistry laboratory and records the result in his lab report. The standard deviation of the student's lab measurements is sigma equal 10 milligrams. Juan repeats the experiment 4 times and records the mean of his 4 measurements. Now let's look at the key words here. And I'm going to outline these in red. It says the standard deviation is 10 milligrams. So there's your sigma right there. One repeats the measurement 4 times. So that's how many times it's repeated. And records, and I'm going to underline this rather than box it, the mean of his 4 measurements. Okay, let's just underline it like this. The mean of his 4 measurements. Okay, see that? All right, so what's the standard deviation of the Juan's mean result? So let's focus on here. The standard deviation of Juan's mean result. See that? It says mean right here. Mean. So we want the standard deviation of the mean. Now, as you know, you have something in your textbook that talks about the standard deviation of a mean, right? And remember what it said. Remember what the standard deviation of a mean is. It's going to be, this is a standard deviation. Let's just make this a little darker. Let's get the size. Yeah. Make it a little darker here. I don't want that. I want this. Let's see here. There we go. So the standard deviation here of the mean, so I'm going to do that X bar indicating it's a mean, will be the standard deviation of the population divided by the square root of n, where n is the number of measurements. So here we have the information. The sigma was given to you as 10. N was given as 4. So the standard deviation of the mean, which is the sample standard deviation, which I'm going to indicate like that, will be 10 divided by the square root of 4, which is 10 over 2, which is 5. So that means, going to here, this answer would be 5. Oops, that answer doesn't look like anything. That's pretty sorry looking 5, so I'll just put it right here. So there's your standard deviation. Now, how many times, now let's take a look here, and let's do this. How many times That's a how many. Must one repeat the measurement to get the standard deviation to 2? Give your answer as a whole number. Well, the standard deviation, now let's take a look at the standard deviation of a sample. So using green, I'll use green down here somewhere. So what this says, and I'm going to go to this, click. What we want is we want the standard deviation now, which is sigma over the square root of n. We're solving for n here. We want that to be 2. Right? Because we want the standard deviation of the mean to be 2. So remember, sigma itself was 10 over the square root of n is 2. Now we have to do a little bit of algebra. Algebra doesn't have to be that complicated. What we can do is just multiply both sides by the square root of n and multiply both sides by, so let's just copy this down here. So we take the 10 square root of n, multiply it by the square root of n, equals 2 square root of n. So the square root of n's divide out, so we have 10 is equal to 2 square root of n. Now divide both sides by 2. We get 5 is equal to the square root of n. And then let's make this a little bigger. Making this a little bigger, what we get is you square both sides. So 25 is equal to n. So there is your answer. See that? That is how you do a problem like that. And that's how you look at this. You have to read everything. And then the key here, again, is the mean of this measurements. As soon as you know it's going to be the standard deviation of a mean, you immediately go to this formula right here. So, okay, now let's look at the second one. Now in this question here, let's read it and let's see what's going on. This level of nitrogen oxides and methane gas in the exhaust over a car, it varies. Let's take a look here. It varies normally. So we're going to talk about the normal distribution with a mean of 85, standard deviation of 6. Company has 16 cars in the fleet. Now, here's a question. Find the level at which the probability and again, here's the key, average. Oops, this is not what I want. There we go. We want the average for the fleet is only 0.01. All right, so what do we do there? We want an average. And we're given that we want the probability of this average. Find the level for which the probability of this average here is being greater than L right here. We want a level. So how do we work with that? Well, here's the thing we realize. Our average will be normally distributed. So we need to use the normal distribution. Now if we could actually start the other way and use a normal calculator, but let's use the tables here. So let's save our work and let's go to the normal tables. And we basically want to start, and we want to say, well, since we're asked to find a level greater than 0.01, let's find z, where the probability of z being greater than, let's call it ZL, Z sub L is equal to 0.01. Well, now the thing is our tables have the probabilities listed as follows. We have it listed like this. So our probabilities have that. So what does this correspond to? Well, it corresponds to 1 minus 0.01, because if the probability is going to be only 1%, that means the probability of this being less than that is 99%. So that's what we want. We want the 0.99. So let's figure this out. And I do have a normal table up here, so let's do that. And this is only part of a normal table, right? And we look for 0.99. And we really are looking for 990. And you scan it, scan it, scan it. This one's pretty good. So let's do that one. We have a 0.990 here. That's close enough. It's only off by 4,000. So let's use that one. And we see that corresponds to 2.30, 2.31, 2.32, 2.33. So from our table, we have that as 2.33. So let's go back to our paint and go here. So going back to this z, which I'm going to call it that, is 2.33. Let me check that again. I'm pretty sure that's right. I already forgot what I said. It's pretty bad, but it's Friday and late and I'm tired. So 2.30, 2.31, 2.32, 2.33. Yeah, that's correct. Yay. So let's go back. All right, so that's the z value we want to beat. But getting back to this, remember that our what we know about the conversion to z, this is going to equal, this is going to be our mean minus our mu over our sigma divided by, and we go down here, 16 cars. So that's the square root of 16. Because remember, n is 16 because 16 cars. Now, remember our mean, our mu is right up here. Our mu is 85. And our sigma is 6. So putting this into play, what we're solving for, and oh yeah, the other thing I should say is that remember, x bar we can assume to be 85. Over a long period of time, that's what it is. So now we know that 2.33 is equal to x bar minus 85 divided by 6 divided, and the square root of 16, let's do that one. That's 4. 6 divided by 4. Okay, which is 3/2. Right, so now we do have to do a little bit of algebra. Now, what I would recommend doing, the easiest way to tackle this one is to multiply both sides by 6/4. You do have to do a little bit of algebra. It is a math class. Then add 85 to both sides. So add 85 to both sides. Six divided by 4, which is the same as 3/2. And then now we can get our trusty calculator here. And I'll just give you a bunch of decimals. And what we get is 88.495. So you could probably round that down to 85 if you wish. But anyway, that's how that goes. So remember, the highlight here is as soon as you realize you're going to try to find a, so here's the upshot here. And I'll just type this because my chicken scratch is hard to read. So the highlight is when you want to find such that the probability of, let's say, of an average being greater than that level is, and let's just call it P. First, find the Z where the probability of Z being greater than P, B is Z greater than Z whatever. So I'm using that lowercase z is P. So find that Z. Use this lowercase z to and equate it with, and I think we'll go back to my drawing board here. Not the best, but let's see here. With, take that z, I don't want that. Turn it. Equate it with. This is a lowercase z. X bar minus mu over sigma over square root of n. That's how you do it. Okay? So thanks for watching, and I'll see y'all next class.